So now today we're gonna discuss about nucleophilic addition elimination reaction. So nucleophilic addition elimination reaction, let's say we have this type of this compound that's react with CH3MgCl, which is in excess. Second, we are hydrolyzing it, so it forms actually first ketone, then reacting with CH3 minus more, it forms the 3-degree alcohol. So what could be the possibility of L? L could be chlorine, bromine, iodine, fluorine, OCH3, OC double bond OR. This all could be the leaving group. Now what is the mechanism does it follow? Let's see. First of all, we have RC double bond OL that is reacting with CH3 minus from Grignard reagent. So it will attack on this side first because it is partially positive charge and it is partially negative. Then the bond flips upwards. And this is also redetermining step. So it will form RCO negative L and CH3, which is a addition reaction. Now second RCO minus L CH3. What happens? It flip backs and the leaving groups leave. So it forms RC double bond O CH3 plus L minus, which is a elimination reaction. Again, which is a elimination reaction. Now let's look at the mechanism further. Now this is elimination reaction, and we have seen further what happens when this eliminated product forms. So CH3 minus attacks over here, this flip backs. Again CH3 minus attacks over there, this flip backs again. But right now it has no choice of any leaving group. There is no leaving group, so it will stay here only. Now let's look at this reaction by examples. Let's talk about very first example. We have HC double bond OCl reacting with first CH3 MgCl second H plus H2O. It forms HC double bond O CH3 first by removing a leaving group, then it forms HCOH CH3 and CH3. Okay. Now let's look some more examples. Second, we have C double bond O Cl and Br. It will react with ATMgBr, which is in excess. Second, H plus H2O. So it will form C double bond O Cl and ethyl. Which one further reacting with ethyl minus, it will form C double bond O ethyl and ethyl. Which are further reacting AT minus, it will form COH, and following by hydrolysis it will form ethyl and ethyl. 3-degree alcohol. Next, third, we have CH3. It will react to form MEMgBr H plus H2. MEMgBr in excess. It is in excess. So the product will be, I am writing the final product. The final product will be CH3, COH, Me and Me. All of you know in first step the OMe group, methoxy group will leave, and that's how it ends. Let's talk about the fourth. CH3 C double bond O OPH reacting with first MEMgBr, that is in excess. Second, H plus H2O. Fifth, CH3O C double bond O OCH3 reacting with first CH3 MgCl, which is in excess, second H plus H2O. Sixth, we have this compound reacting with MaMgCl, that is in excess, with H plus H2. Let's look all these three products. First of all, it will form CH3 COH Me and Me. It will form CH3 COH CH3 and CH3. Again, same product. And right now, what happens that Me minus attacks over here, this ring flips up and this leaving group leave. Double bond no Me. O minus it will form no further on hydrolysis. It will form OH Me Me OH. Seventh, first MEMgCl, which is in excess, second NH4Cl and C double bond OPH. MEMgCl, which is in excess, second H plus H2O. Ninth, CH3O C double bond OPH. First PHMgBr, which is in excess, second H plus H2. Now pause the video and try to answer by your own. Now let's look about the answer. It is will form two products, COH Me and Me, plus diol. This will how Mg minus react with this. First bond flips, then it comes, then it also comes, then also 3 moles of MgCl will attack over here. Now on further hydrolysis, it will form diol. So I hope you all got how do we do this reaction. Like second one, if we talk about H, Ma plus PHOH. Third, PHCOH, pH and pH. Let's solve some more problems. 10th, first CH3 MgCl, which is in excess, second H plus H2. How does it react? OH Me OH CH3 then OH. Now this type of reaction occurs. Now we're gonna talk about reaction with anhydrides. Now we're gonna talk about reaction with anhydrides. Now how does anhydride react? We have CH3 C double bond O C double bond O CH3 reacts with first ATMgBr, which is in excess, second H plus H2. So it will form CH3 C double bond O AT plus CH3 C double bond O minus. This will convert to after hydrolysis OH. Now look how does this reaction happens. Now in second part also the reaction is still not completed. In second part also we have CH3 C double bond O ET, which will react with ATMgBr minus inner region. It will attack over here. The reaction will go up. CH3COH ethyl and ethyl will come here. So that will be the final product. What will be the final product? This one. No. Acid, and we have this 3 degree alcohol. Acid and 3 degree alcohol, right? Now look some problems regarding to that. First we have CH3, C double bond O. pH. First it will react with CH3, MgCl. Second H plus H2O. Now what will happen? We have only excess of CH3 Mg. We have excess of this. So where it will attack? CH3 minus will attack, could attack either with phenyl 1 or with methyl 1. So where it gonna attack? It gonna attack on methyl 1, because phenyl 1, this double bond is going in resonance. This double bond is in conjugation with phenyl. So it will not attack over here. Now it is already stabilized, so it will attack over here. Now what will form? CH3 plus pH, C double bond O minus. So this will attack CH3 minus also. So CH3, C O minus, CH3 and CH3. It will form this. Now let's solve some more problems. First, this will react with ETMG, MEMGBr. Second, H plus H2O. So the final answer will be OH, ME. OH. This will form. Right? Now let's look about second problem. Again we have similar type of reaction, but benzene is along with it. So first we have MEMgCl, which is in excess. Second we have H plus H2O. So the final product again will be similar to this, which was how it is forming. We know then Me minus will attack one of this side. This bond will go up. Now this will leave. Now this will leave. OH will come here, and after hydrolysis it will form acid. So that's how the reactions takes place. Now let's talk about third reaction. In third reaction we have a nitro group attached. So the nitro group attached, so we have still MEMgCl, which is in excess. Second H plus H2O. So MEMgCl will attack over which side? The just opposite to NO2 or the meta position to NO2, which will attack over here? So NO2 has a tendency minus I effect over the ortho and para position. So in its para position, it will create a delta positive charge. It will intensify the delta positive charge. On the ortho position, it will intensify delta positive charge because it has minus M affected ortho and para position. So it will intensify. So Me will attack ortho position to it. So Me will attack over here it. So this will bond will go. So it will form NO2 CO minus Me methyl acid. Fourth, we have methyl over here. Which will attack MEMgCl, which is in excess. Second, H plus H2O. So it will react to form CH3. Now where it gonna attack? Now it will attack on opposite side because it will de-intensify the positive charge. Here we have delta positive, here we have delta positive. So CH3 will show plus I effect over here, plus H effect over the ortho position, which will de-intensify the positive charge on the ortho position and intensify the positive charge on the meta position respectively, relatively. So CH3 will intensify the, because it has plus H effect on the ortho position. So it will de-intensify the delta positive on the ortho position and it will intensify the delta positive on meta position. So that's all, that will be the product. Let's talk about the fifth. Fifth, we have this compound. Now first MEmgCl in excess. Second H plus H2O. So it will form two products, methyl plus HOC double bond O. This one. Sixth, now we have a condition where we have two position to attack. We have NO2. So it will react with first MEmgCl, which is in excess. Second H plus H2O. So it could attack over here also and here also. So it will attack where the intensity of negative charge is more, which will be created by nitro group. Nitro group will having a minus M effect over here. So it will intensify the positive charge. So Me will attack over here. So when Me will attack on the side of opposite to the NO2 position, so the answer is pH, C double bond O minus plus. NO2. Now this will further react with Me, H3O plus, Me minus H3O plus, COH, methyl, NO2.